Hi everyone, welcome to my channel. This is Quantum Unicorn. If this is your first time tuning into my program, I want to let you know that all the demos and the data files in my program are free to download. You can find these files by clicking the link below the video. And if you are a returning viewer, I hope you have taken my advice and spent some time practicing the code we covered in our last episode. And just a kind reminder, this course is meant for educational purpose only. The data and the information presented in this video is not investment advice, okay? And please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Thank you. In the last video, which was the hypothesis testing episode, our emphasis was on explaining these concepts in statistics and introducing their applications in the finance field. Considering that you now have a good understanding of the above content, today we will do a detailed breakdown of the Python code for each module. By gaining a deeper understanding of the application of Python code in these specific scenarios, you will be able to better grasp the topic we are learning and lay a solid foundation for future learning. How exciting! Well, let's get started. I'm going to skip a few lines of code, which I believe we have discussed many times. So I'm gonna start from the third cell. Okay, here's the code. PLT title, daily return of Microsoft from 2014 to 2017. The first line of code sets the title of the plot to daily return of Microsoft from 2014 to 2017 with a font size of 20. And the second line of code generates the actual plot. Specifically, it plots the daily log return of Microsoft stock over the period from 2014 to 2017. The MS log return code selects the log return data from the MS data frame, and plot function generates the plot. The fixed size parameter sets the size of the plot to be 20 inches wide and 8 inches high. Okay. The third line of code adds a horizontal line to the plot at the y-axis value of 0. This is a common technique in finance to visually indicate the 0 line, which is often used as a benchmark for stock performance. The color parameter sets the color of the line to red. And the fourth line of code adds a label to the x-axis of the plot. Specifically, it labels the x-axis with the text time and sets the font size to 10. And similarly, the last line of code labels the y-axis with the text daily return and sets the font size to 10. Overall, this code generates a plot of the daily log return of Microsoft stock over the period from 2014 to 2017 with the title, x-axis label, y-axis label, and a horizontal line at y equals to 0 to indicate performance relative to the 0 benchmark. Okay, moving on to the next cell. PLT title. The first line sets the title of the plot to close price of Microsoft from 2014 to 2017 and sets a font size to 10, right? And these two lines set the x-axis and y-axis labels to time and US dollar respectively, and both with a font size of 10. And the fourth line actually creates the plot. It uses the plot function from matplotlib pyplot to plot the closed column of the MS data frame, the MS log syntax is used to select only the closed column. The colon before the comma indicates that we want to select all rows, while close after the comma indicates that we want to select the closed column. Overall, this code generates a simple line plot of the daily closing price of the Microsoft stock from 2014 to 2017 with appropriate labels for the x-axis and y-axis. Okay, moving on to the next cell. The first line sets the title of the plot to histogram of daily return of Microsoft from 2014 to 2017 with a font size of 10. And the second line accesses the log return column of the MS data frame using the log method. The drop-down method drops any missing values in the log return column. And the hist method creates the histogram of the log return column using 100 bins and sets the size of the figure to 10 by 4 inches. Overall, this code creates a histogram of the daily return of Microsoft stock from 2014 to 2017. Okay, moving on to the next cell. X bar. Well, this line calculates the simple mean of the daily log return of Microsoft, where MS log return is a panda series containing the log returns of Microsoft stock prices. As the second line calculates the simple standard deviation of the daily log return of Microsoft, where DOF equals to 1 specifies that the calculation should use the unbiased estimator. And the third line assigns the sample size of the daily log return of Microsoft to n, where MS log return shape 0 returns the number of rows in the MS log return panda series. And z-hat. This line of code calculates the z-score of the sample mean of the daily log return of Microsoft with respect to a null hypothesis mean of 0. The resulting z-score, z-hat, represents the number of standard errors away from the null hypothesis mean that the sample mean is. Okay, well done, moving on. This code is related to hypothesis testing. Specifically, it is checking whether the population mean of the daily log return of Microsoft is significantly different from 0 at a 5% significance level, which is alpha. It calculates the left and right critical values, z left and z right, for a two-tailed test using the normal distribution. In statistics, the normal distribution is a continuous probability distribution that is widely used to model real-world phenomena. The norm PPF function in Python's SciPy library is used to calculate the inverse of the cumulative distribution function of the normal distribution. The norm PPF method calculates the value of the standard normal distribution corresponding to the probability alpha over 2 in the left tail. In other words, it finds the z-score that corresponds to the probability of alpha over 2 to the left of the mean, assuming a standard normal distribution with mean 0 and standard deviation 1. This value is often used in constructing confidence intervals for population means and hypothesis testing. By calculating the z-score corresponding to a given level of significance, we can determine the range of values that the population mean is likely to fall within. Okay, moving on. This code is checking for the statistical significance of a sample mean. Z right equals to norm ppf. Well, this calculates the z-score at the upper tail of the standard normal distribution corresponding to the significance level. The first argument is the probability value. The second and third arguments are the mean and the standard deviation of the normal distribution respectively. In this case, since we are using the standard normal distribution with mean 0 and standard deviation 1, we pass in 0 and 1 for the second and third arguments. And the third line prints the calculated z-score at the upper tail of the distribution, z right, and the previously calculated z-score for the sample mean, z hat, right? And the last line checks whether the null hypothesis should be rejected or not. If the z-score for the sample mean is greater than the z-score at the upper tail of the distribution, then we reject the null hypothesis. If z hat is less than z right, then false is printed out, indicating that the null hypothesis should be rejected. Okay, moving on. This code performs a hypothesis test where the null hypothesis is that the population mean is equal to 0, and the alternative hypothesis is that the population mean is not equal to 0. The z-score is calculated and stored in z hat, which is roughly equal to 1.6141. The significance level is set to 0.05. The p-value is calculated using the cumulative distribution function of the standard normal distribution, norm CDF, with the absolute value of the test statistic, NP, EPS, Z hat. I think NP stands for long pi, and the mean of 0 and the standard deviation of 1. The p-value is then doubled to account for a two-tailed test. The resulting p-value is stored in p. And finally, the script prints the significance level, the calculated p-value, and whether or not the null hypothesis should be rejected based on the calculated p-value, and then the chosen significance level. If the p-value is less than the significance level, the null hypothesis should be rejected. Otherwise, it should not be rejected. Congratulations, folks! That's all for today's tutorial. And remember, practice makes perfect. Practice makes perfect. Practice makes perfect. So keep working hard and experimenting with what you have learned. And if you still have any questions or feel that you have not fully understood or need more explanations from me, please express your needs in the comments section. I'm more than happy to help you out. And speaking of comments, I'm always open to your feedback and suggestions. So if you have got any thoughts on how we can make this program even better, please don't be shy about sharing them. Oh, and if you haven't already, I would love it if you could subscribe to my channel to stay updated to my latest videos. And if you have friends or family who would also appreciate the knowledge of building stock trading models in Python, please feel free to share my videos with them. I truly appreciate your support, and I'm excited to continue sharing more tutorials with you on my channel. Thank you again for your time. I wish you well and look forward to catching you all in the next episode. Goodbye.